Hi everyone, today I will talk about the stationary points. So in this topic, it is differ from the previous topic of stationary point where in this topic it involves more than one variable. So in this case we have function of x and y variable. Okay, where in previous chapter we only deal with the one variable which is x. So in this chapter, we will learn about the partial derivative of the two variables. So let's go to the definition of the stationary point. So the stationary point of fx and y occurs when del f over del x equal to 0. And we have also del f over del y equal to 0. So of course, we have to consider all the variables in that function. Okay, so when we have this characteristic del f over del x equal to 0 and del f over del y equal to 0, we can find the two equations, okay, by using this formula. So when we have the two equations, we can find value of x and y. So when we have the value of x and y here, x and y n. Okay, so when we have value of x and y n here, we can substitute the value into the Hessian function. Okay, so to get the why do we need to substitute into the Hessian? So in the Hessian we can find whether the function, the points itself is a maximum point or a minimum point, or can be saddle point. Okay, or might be no conclusion. Okay, so this is the properties of the Hessian itself. So when h is negative, okay, we will have saddle point. If we have h is positive here, we will have two options here, whether it is maximum or a minimum. So we need to do another assessment, okay, where we have to find the value of del square f over del x square and del square f over del y square. Okay, if it is equal to less than 0, which is negative, okay, so means it is a maximum point. If both value are positive, then it is a minimum point. So and the last one is if h equal to 0, okay, so the test fails or no conclusion. Example here, find and classify the stationary points of the given function. So in this function, first we have to look at the number of variables. So we have the variable x and y here. So it is considered as partial derivative, where we need to find the stationary point by using partial derivative methods. So since we have only two variables, we need to find del f over del x equal to 0. And we need to find also del f del y and equal it to 0, because stationary points always get del f over del x equal to 0 and del f over del y equal to 0. So first we find the del f over del x. So differentiate x square, we get 2x plus y. Differentiate y square, we get 0. Differentiate 5x, we get 5. Differentiate 5y, we get 0 and 3 equal to 0. Okay, then since we have equal to 0, then we put equal to 0 on this side. So we will have the first equation. So next we find the f over del y. So the f over del y differentiate towards y. So x square 0. xy we have x plus 2y. 5x 0 minus 5y we get minus 5. Okay, then we also equal to 0, since in this formula we have equal to 0 to find for the case of the stationary points only. Okay, so we will have two equations. Okay, so we have two equations. Then we want to find the points. So how to find the points? By using simultaneous equation. So I just copy this one back. So we have, let's say we have two. So this is the first one. And then we have another one. X plus 2y. So it looks like if I want to substitute maybe I can substitute 2 into 1. Okay, so I simplify this one. X equal to 5 minus 2y. So we get the edited equations. So we just substitute 2 in 1. So we have 2x, we have 5 minus 2y plus y. Just substitute this one. Plus 5 equal to 0. Then we have 10 minus 4y plus y. Then we have minus 3y equal to minus 15. So we have y equal to 5. Okay, so we have y equal to 5. So next I can substitute into either of the equation. Okay, so let's say I want to choose for 2. So we have x equal to 5 minus 2y. So we have 5 minus 2, 5. Then we have minus 5. Okay, so we have the points, stationary points occur at xy. So we just rearrange into negative 5 and 5. Okay, so next we have already got the stationary points. Okay, so in the second step we want to classify the type of function. So in order to classify the types of the function, the point itself, we need to find the Hessian. Okay, so I just copy back. So we have this now, we have del f over del x equal to 2x plus y plus 5. We not equal it to 0. Okay, so since because we need to find another derivative, del f over del y. So we have x plus 2y minus 5. Okay, so to get the Hessian, so we need to find del square f over del x square, del square f over del y square, and also del square f over del x del y. So first we find the del square f over del x square, we get del over del x. So inside here we find del f over del x. Okay, so del f over, so I just substitute this value. So this one we already find. So we have del f over the x here, 2x plus y plus 5. So we need to differentiate this one in terms of x after we have substitute. So we get the value 2. Okay, differentiate y 0, 5, 0. Next we find del over del y, del f over del y. So equal to del over del y, del f del y. So we have x plus 2y is 5. So differentiate towards y. So at 0, 2y, we get 2 also. Next we have del over del x. Here we have del f over del y equal to del over del x. So del f over del y is equal to x plus 2y minus 5. So we differentiate towards x, we get only 1. Okay, so the formula of Hessian, we just substitute. So 2 multiplied by 2, then minus 1. We get equal to 4 minus 1 equal to 3, which is greater than 0, means positive value. So there are two possibilities here, whether it is a maximum or minimum. So how to know which one? We need to check for the del square f over del x square. So look at the del square f over del x square. So we just look here. So this is del square f over del x square. This one is greater than 0. So del square f over del y square also equal to greater than 0. Okay, so we know that it is a positive value. Okay, so we can make conclusion. So since h positive greater than 0, which is positive value, and then we check for del square f over del x square and del square f over del y square, okay, also greater than 0, so it is minimum value. Okay, so what does it mean by it? The point itself. So here we have the point of 5 and -5. Okay,